Okay, getting the live stream started. All right, again, so the live stream is started. Good morning. We're going to look at the human growth population unit. So again, look at the vocabulary while we are waiting for folks to log in. Yes, it's small. Someone noted that the vocabulary list is not yay long this time. However, this one has a lot of graphs. So while there are not that many vocabulary terms, most of these terms come with graphs and charts and things that we need to be able to address. So don't let the short list fool you. This is still a very involved unit. Okay. All right, wait a few more minutes for folks to come in. And again, after you've looked at the vocabulary list, give a quick look at what is population, because that's what we're going to really address today. And even though the unit says human population, we're going to start off by talking about population in general. And then I'm going to have you do a specific activity that deals with human population in your area. All right, give folks another minute and then we'll get started. Um, all right, so again, I have to remind you that if you're logged in, you need to be on camera. You need to not just log in and be idle. So we are going to watch a video. And I expect you to take some notes during the video, so grab some paper so that you can jot some things down. There are four distinct topics in this video that you need to take note of, and then you're going to use that information to talk about Muskogee County. So again, please look at your Canvas unit on human population and what is population. Okay, I'm going to go ahead and get started. I believe there's just one person that isn't exactly logged in. Two. All right, so we're going to go ahead and get started. All right, so again, we are looking at population today. And we're going to start off with a video. And again, there are 4 distinct sections to this video that want you to jot down some notes. So we're going to look at how to count the population, quadrant sampling, carrying capacity, and density dependent and independent factors. So there are 4 different sections to this video that I want you to take note of. I'll pause it from time to time, but I won't pause it that much. So try to be aware of what notes you need to take. Definitely the notes pertaining to the title, the description of the activity that they are doing. All right. All right. Oops. Okay, let me come out for a minute. I have to adjust the volume. Tend to forget that. Okay. All right, so in Canvas, let's go ahead and just look at this introductory video, right? This is very short, but it just in general talks about population. It doesn't talk, it just shows you about population. All right, earlier in the year, we did a breakdown of looking at how you classify organisms in the biosphere. So we started off with an individual, which would be your species, and then you had a group of that particular species, and that was defined as our population. So a population is one kind of individual. And then when we put different kinds of populations together, we had a community. So today we're just looking at population. All righty, so have your pencils and papers ready. Okay, we're going to skip the ad. And I need to turn the sound on.
Hi everybody and welcome back to Miss Angler's biology class. I am Miss Angler. In today's video, we are going to do the introductory episode to
Sorry, hold on. Sorry, I hit the wrong button. Okay, there we go. We're back.
videos I will make on this topic. Some of the other topics that we will still cover will be things like different types of growth curves, predator-prey relationships, and so much more.
All right, so if you're taking notes, the title of your notes should be Population Ecology. Again, this is divided up into 4 topics. So this first segment is just general information as far as definition is concerned. You don't necessarily have to write down the definition because you have it in Canvas. But then when she starts a topic of counting, that's when you need to start taking notes.
But in this particular video, we're going to look at what a population is, how to count it, and what are the factors that affect the size of that population. Now, if you are new here, don't forget to give this video a thumbs up and make sure your notifications are turned on and you're subscribed because I post new videos every Tuesday and Thursday. So the first most important component of our understanding is what exactly is a population. So when we speak about population ecology, we are talking about a group of individuals that are the same species and they are found in the same place at the same time. And so that's why when we talk about populations, we can talk about populations that are perhaps in a country, like a country's population, but we can also talk about the human population too, and that's all the individuals together. Now, when we look at population ecology, we specifically focus in on the things that affect their numbers. So what is making the population bigger? What is making the population smaller? And there are four key components that you need to know and understand how they affect the population. Starting off with this picture here, we have a little group of small birds. Let's say they are a group of sparrows, and we need to see what affects their population. So the first thing we look at is births. Now, births have a positive influence on the population, which means that they add more individuals. However, on the other side, deaths is going to be a negative influence, and that then means that we minus individuals from that population. Then we have immigration. Now, immigration is often confused with its sister immigration, but essentially immigration is when individuals are moving into a population. So this has a positive influence on the population numbers, you adding individuals, whereas immigration is removing individuals. And a nice way to tell the difference is immigration's like exit. So
All right, so I'm gonna pause it right there. So the first thing you need to write down, there's 4 factors that affect population. And you want to write them in terms of positive and negative. So you want to say births, add to the population, deaths, take away from the population, immigration, adds to the population, emigration, takes away from the population. So 4 factors: births, deaths, immigration, emigration. And like I said, you don't have to write a lot of definition to it. Just say births and then add to the population, deaths, take away from the population, emigration, adds to the population, emigration, takes away from the population. Four factors that affect population. Okay, I'm going to start it up.
So it's leaving. Immigration sounds like in, like they're moving into the population.
Hey guys! Today we're going to learn how to add this scrolling animation to your website in Wix Studio.
There we go.
Now, an important component of population ecology is being able to actually count populations. But the problem is when it comes to counting organisms is that they don't all behave in an easy way for us to actually count.
Pause it because this is your first other subheading, counting population. So you want to take notes on counting populations.
So we've two main ways that we're going to learn now about how we can count organisms depending on whether they move around or if they stand still and make it easier to count. We're going to start off with organisms that move around, and we're going to start with the method of mark and recapture using a specific formula, and I'm going to use these snails to demonstrate how you actually calculate this. Now what we do is we use this particular formula we see alongside, and you should always write this out in an exam because you always get like a mark for writing the formula.
Okay. All right, so write the formula, write what those letters mean. So then the process is called count and recapture.
But let's break down the letters, and I'm going to show you how to apply it to our snail population here. So N is the estimated population. That's what we're trying to solve for. M is the total amount of organisms we captured the first time. C is the total amount of organisms we captured on the second time, hence the name mark and then recapture. And R is the total marked individuals that we caught on the second time that were already marked. And you'll see now what that looks like once I use it in this snail example. So applying it to our snails, let's say these are the snails that I have caught in my first grouping. So I've caught them now. And what I need to do is I need to actually mark all of them. So I would go along and I would mark each of them on their shell. And it's important, and you would need to know this also for tests and exams, that when you mark your snails, your animals, whatever you've caught, you need to make sure that the way in which you mark them doesn't hinder their movement, it doesn't hurt them in any way. And when you put them back into nature, you need to put them back where you found them or relatively close to that. And when you do the second capture, so when I go out again, let's say 2 to 3 days later, I need to do it in a very short period of time. I can't come back months and years later to do the second capture. So let's say, for example, I've gone out now and I've caught all these snails, and we have 1, 2, 3, 4, 5 by 4. So we've got 20 individuals here. So in my first capture, I have got, and let's put it into our formula, N equals 20 multiplied by, and now we're going to do our second capture. So I'm going to come back 3 days later and I'm going to count my next group of snails. So I've gone out and I've caught my second group of snails, but you'll notice that this second group of snails has some that are counted and already have a little green mark on them, and then others don't. What I need to do is I need to again count the total population that I've caught the second time around. So the second time around, I still caught 20, but now we need to divide this number by how many individuals were already recaptured. So let's actually just count. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 snails that were already marked, which means that I've counted them actually for the second time. Now what you need to do is take this and calculate it in your calculator. Now this gives us a population of 36,36. But it's important that you don't leave the answer as a decimal, because you can't have like a third of a snail. You need to have a whole number. And so you actually need to round down, which I know conflicts with what we do in maths. We generally round up if it's more than or less than. But in this instance, we're always going to round down. It doesn't matter if this was 36,5, you must round down so you get a whole number. And so this is the estimated number of snails in this particular area of 36.
Okay. Every time she changes subjects, they'd have a commercial. But we'll get past that. Now,
in the past at college, I've struggled with overusing the same words again and again in my essays. I do a lot of writing and tools like...
Okay, I'm going to pause. Why do you think they round down and they don't round up? In other words, why can't you have 36.5 snails? Anybody? Why are they rounding down instead of up?
Because the last number is smaller?
No, because not exactly. Ethan says because you mess up the population count if you round up. Yes. Okay, but basically we don't want to have half a snail. Because 0.5 really indicates that there'd be half a snail. So it's more, well, and then remember the thing said it's an estimate. So we're estimating, let me come back here for a sec. Oh no, that's bad because then the commercial will come back. But this is an estimate. Okay, N is an estimated population. So it's okay that we're off by 1 because this is an estimate, but we don't want to have half a snail or half a human or something like that. So we take it to the closest whole number with going down and not up. Okay. All righty. Let me see if I can't skip that commercial. All right. So now she's going to talk about quadrant sampling. So rate that as a heading. And hopefully I didn't go past where she starts talking.
To count how many individuals are in that specific sample area. Now, quadrat sampling is great for organisms that don't move very much or are completely immovable.
All right, so that's what you want to say. You want to say it is a measured area, and they use this method for organisms that don't move very much. All right, so using this wouldn't help if the animals are always moving in and out and all over the place. So this would do good for plants or for things that are in the soil and they're not going to move out of a particular area very much. Okay.
Because you use a plastic or a metal square, a 1 by 1 meter square, to see how many individuals are inside of that square. And so when you place it down, you don't want them to be able to move very quickly because otherwise they'll just walk over your quadrat and out of your area. So this is great for things that move slowly or don't move at all. One thing to keep in mind though when you are quadrat sampling, and you can have a look at the diagram on the left here, is if we are counting, for example, these crabs, you're going to count the crab that is mostly inside of the quadrat. If you get an individual who's on the edge or it's got most of its body on the outside, you're not going to count it. So in this example, you should know that there are 5 crabs in this quadrat and not 6. But let's actually apply it to the picture we see on the right-hand side, which is a representation of a field of sunflowers. Each one of those dots represents a sunflower. And I need you to know that one of these blocks is 1 by 1 meter, and it's going to form that square meterage that we see in the diagram. It's really important to figure out what it is. There are 10 by 10 blocks, so that means that this is 10 meters and this is 10 meters. And we need to know the size of the area we are working with when we do the calculation and when we calculate the estimated population size. Now, the next thing we need to do is we would take a random selection of samples of the quadrats. And so each of these squares represents 1 quadrat. And I'm going to select 5. 1, 2, 3, 4, 5, right? Those are our 5 random samples. And now we need to count how many individuals are in each. So in quadrat 1, we have 1, 2, 3. In quadrat 2, we have 1, 2, 3. In quadrat 3, we have, again, 1, 2, 3. In quadrat 4, we have 1 and 2. And in quadrat 5, we have 1, 2, 3, 4, right? So you're going to take all these individuals. Now you're going to add them to get a total. So we've got 9, 10, 11, 12, 13, 14, 15. So in total, we have 15 individuals. We are now going to take those 15 individuals and we are going to divide them by 5 to get an average of how many are in each of the quads, and that gives us 3. We then take that 3, and what we need to do is we need to multiply it by the total amount of quads we have, which was 10 by 10, which means we have 100. And that means our estimated total population size is 300 sunflowers. Again, everybody, if you ever get a decimal answer, you always round down.
Okay. And there's another commercial. So that was carrying.
Your child needs these 3 key factors to get into an Ivy League or top 25 university.
Now, once we start counting these
All right, so next one is carrying capacity. All right, so quadrant sampling, again, you're not standing out there trying to count all of them. You're, again, estimating based on a small sample. Then you assume that they're evenly spread out so that you create I like to call it a guesstimate of how many in that particular case, sunflowers there are in that particular quadrant. All right, so this is our third heading, is carrying capacity. Now, again, I told you with some of the vocabulary that we have, we're going to have graphs. So this one has a graph, okay? And so just take a minute to do a rough graph, sketch of this graph, so that you understand, because that line, that dotted line at the top, that indicates carrying capacity. So this one, you need a visual. So again, just draw this, and then in this case, they're going to talk about numbers of rabbits, and it's over time. So it's always the number of the population over time, and that's going to be your carrying capacity. And there's some other labels that go with this graph, but she'll talk about that as we go on.
Populations, we can use them to plot graphs, and we can create a number of how many individuals we have over every single year, and we can start to see what the population is doing with its numbers. Now, it's interesting to know that when we do these counts, there is actually a maximum number that an ecosystem can support. And that's where the carrying capacity comes in. It is the maximum amount of individuals an ecosystem can support. And if it goes over that number, you often see a decline in the population. Now, what actually is the carrying capacity? It is everything from the resources available, like food, shelter, space. That creates a maximum number. And if we have a look at the graph here, we have time and we have the number of rabbits in a population, and then we have the carrying capacity. So that's the maximum amount of rabbits that we can support. You'll notice in this graph, the number of rabbits starts to slowly increase and then dramatically increase because it's got lots of resources. And then when it gets to the top here, and it reaches the carrying capacity, it levels out, it flattens out. And that's because there are fewer and fewer and fewer resources, because there are more and more rabbits using those resources. But there's a little bit more to this story. If we look at the same graph again and we insert the carrying capacity here as the dotted line, the carrying capacity can actually move down and it can move up depending on how many resources and individuals there are. So what I mean by that is, if there are far too many individuals, the carrying capacity can move down permanently. And that's because you have removed so many resources that it can move down. However, if an area is opened up, maybe there is a new piece of land that now plants and animals can go into, and maybe humans have moved away from that area. So a whole new ecosystem opens up. That means the resources increase, and so the carrying capacity can also increase. But something also that maybe we are not aware of is when we talk about carrying capacity, we must also know that the graph is never this smooth like we see in the first drawing. In actual fact, if this is the carrying capacity, when a population is approaching that line, so it goes slowly at first, and then when it gets to this top part of the carrying capacity, it often actually overshoots it. And what that means is there's so many individuals, they're rapidly reproducing, there's lots of resources, and then all of a sudden there are way too many of them. And what does that cause? It causes a dramatic dip in the population. Once it's done this overshoot, it actually self-corrects really well and doesn't drop all the way back down again. It will come back up and then level out a lot better. If it doesn't do this perfect leveling out, what can also happen is it can go up and overshoot and then fluctuate gently around the carrying capacity. And that's often the most common and realistic growth curve, is where you fluctuate slightly above and slightly below the carrying capacity over time. What we also need to talk about is what is keeping the population curve below the carrying capacity. So what's pushing down on it when we look at these diagrams? And often in textbooks, you'll see these arrows pointing down, and that represents what we call environmental resistance. And environmental resistance refers to basically the limit of resources that are available in an ecosystem, and the environmental resistance resists the population growing.
All right, so make sure, so what you really need to know with this one is carrying capacity is dependent on available resources. And the available resources will create an environmental resistance. All right, so I told you that this particular one has graphs. So you need to be able, if you are presented with a graph, be able to explain what that graph is telling you. Now, in this case, it's just a general graph, but one that you would get on a test would have numbers. And so that you would be able to look at the actual population. They would ask at what population size would, in this case, the number of rabbits start to slow down. And they might ask you why. Okay, so your answer would have something to do with the resources. And remember, resources are going to be food, shelter, water, everything that they need to survive. Okay, now this is just talking about the number of rabbits. It could also have something to do with the predators in the area. How many predators are keeping the population of rabbits down? So that could be a factor too. But most of the time we just deal with looking at one population at a time and not looking at those extra factors when we're talking about carrying capacity.
And so it does play an important role essentially in creating the carrying capacity. So just to clarify the difference between the two words, the carrying capacity is the maximum amount of individuals an ecosystem can support. And that carrying capacity is created by the environmental resistance, which is linked to the resources and the amount of resources that are available. And it is the force that is pushing down on a population, and it prevents them from overshooting the carrying capacity and staying above the carrying capacity.
I'd do anything.
My baby's got a sensitive stomach.
My baby needs some.
Now, what we need to also focus in on is these factors, these things that are influencing the size of a population.
All right, so write these. This is your last heading. Density dependent and independent factors. And as she said, these are factors that are going to influence the size of the population. Density has to do with how thick, how many organisms are in a given area. What factors is that dependent on, and what factors don't have anything to do with population?
The things that create the carrying capacity, that create the environmental resistance. And that is where the density dependent factors come into play and the density independent factors. Now, when we speak about density dependent factors, the examples that we use are things like food, space, shelter, predation, and disease. And these are the things that are linked to density dependent because...
I'm going to pause that there so that you can write it. Density dependent is food, space, shelter, predation, and disease. All right, so it's like I was saying earlier, carrying capacity is not as cut and dry as how many individuals are there. It depends on some things.
It depends on how large or how dense a population is. So sort of think of it like this. When we talk about the food dependency, right? If there are more individuals, so there's a higher density, there will be a greater need for food. Likewise, if there is more individuals, there's going to be actually more disease. So these are the factors that control a population, and they are based on how big the population is. Another one, for example, is predation. The more there is of prey, the more predators an ecosystem will then provide to maintain the population numbers. On the other hand, we have density independent factors. Now, these are factors that are not linked to the size of the population, and they are rather linked to natural phenomenon. And the two main ones are climate and natural disasters.
All right, so write those two down. Okay, so independent again means it's not dependent on the size of the population. Or not size related.
So sort of think of it like this. It doesn't matter how many individuals there are in a population. The natural disaster that comes along, let's say it's a tsunami. The tsunami that wipes out the population, it didn't matter if it was a big population or a small population. So when we control that population size, it didn't matter how big it was independent. And this natural disaster occurs and it affects the whole population. Likewise with things like climate, so think like drought or floods. Again, that's not directly linked to the size of the population. If it's a big population, it's not going to create some kind of flooding situation. So when these independent factors occur, they are independent of how big the population is, and regardless of the population size, they will equally be affected. Every individual. There's no survival of the fittest necessarily. There is no bigger or better or adapted. They are all equal, and they all succumb to the drought, the flood, or the tsunami. Now, as always, I like to end off my lessons with a terminology recap, and you can use all of these terms to create flashcards and to study from, or to mind map out your ideas, or a blurting method is really good for this kind of thing, so you can write down the word and everything you remember about it. But we first of all looked at population, which, remember, is a particular group of organisms in the same place at the same time, and they are the same species. It's important that you know the difference between population and the definition for species. Then we looked at how birth and death have a negative or a positive impact on a population by adding or subtracting individuals. We also looked at how immigration, which is the movement of individuals into a population, versus emigration, which is individuals leaving a population, how they impact the overall population numbers. We looked at two methods that we count individuals. We use mark recapture for organisms that move around a lot, and we have to capture them more than once. We used a quadrat method for organisms that are either really slow moving or they don't move at all, and we count an average and we get an estimate. We spoke about the carrying capacity, which was the maximum amount of individuals an ecosystem can support, and that carrying capacity is based off of the environmental resistance that occurs. That is when the environment resists the population's growth. And finally, we looked at the two types of density factors that can influence the size of the population, which was the density dependent, which is linked to the size itself. The bigger the population, the more problems, the less food, the less shelter. Whereas density independent factors are not linked to the size of the population and are rather linked to things like natural disasters, climate change, things that are not necessarily linked to the size of the population. Now, if you like this video, don't forget to give it a thumbs up and make sure you are subscribed with your notifications turned on, because I post every Tuesday and Thursday.
All righty. So hopefully you took good notes on that. All right. I'm going to send you a link, and I want you to kind of come local with your so your assignment is going to be to study the population of Muskogee County. So I'm going to put this link in the chat. I'm also going to repeat it on the assignment folder. All right, so the link is in the chat. So I want you to take notes on this one. So this one is the website that gives you the information about Muskogee County. So we want to know, what is the population size? How did they determine that? And they're not going to do quadrant sampling now. How do they determine population size of Muskogee County? And this goes through a lot of have questions or headings. So you want to take the headings and jot down a note about each of these headings. Okay. And you want to stop. Okay, stop. You don't have to know the size of the US population. You want to stop with age and sex demographics of Muskogee County. Okay. All righty. So you want to talk about, in your conclusion, you want to talk about, is the county population growing? Is it getting smaller? And what might be the reasons for this change in population? All right. So so you're writing a paper, a little research paper. You're going to use this website to do so. And I'm going to put a definite assignment folder in. I also repeat this link in that assignment. And that'll pop. I'll let you know when it is available. I'm going to come out, make sure I do attendance, and then I'll put that assignment in the folder. So again, start off by using the questions that they ask and answer them. And then we want a conclusion statement. Of course. All right, so I've sent out a link. Everybody should be looking at the link. Yes, put it in your own words. So you're not copying and pasting, folks. You are answering the question in your own words. It's blocked. Okay, hold on. Let me see if I can't get it unblocked. Is it blocked for everybody? I tell you what, I'll work on getting this particular one unblocked. See if you can't find one that isn't blocked. I see somebody's in. Janila, how is it that you are on the site and is there anybody else who says it's blocked? Yeah, I see I see a couple of people who are in. So,
it could just be one of their teachers because I'm on it with no problem.
Yeah, I see quite a few people on with. The question, you are on the website and you are answering the question. They have several subheadings. So for example, the first question asks you, how has the population in Muskogee County changed? So like as Imani asked, do you put it in your own words? You need to say so give the year and state what the population is and how it's gone up. So it was in 2022, it was a certain number and it's gone up since 2010. You need to say what that is. Okay, that's all you don't have to copy. I'm not looking for you to copy and paste that statement. In your own words, you want to answer the question, how is the or just start with what is the population of Muskogee County? So you say, as of 2022, the population is, and it has gone up since I'm looking at this now, 6% since 2010. That's what you want to say for the first one. And then go ahead and, yes, use Google Docs to answer the question. Yes, indeed. Yes, indeed. All right. Anybody still blocked?
Wait, you said what questions do we use?
Okay, I'm going to share this again. Hold on one second. Okay, folks, so I'm document. All right, so for example, you want to, you see the bold statements, those are your headings. Okay, so you're answering, all of these are questions. You want to answer these questions. Okay, so start with, and you don't have to even say, you can answer it by just saying the population size of Muskogee County as of 2022 was, and that's probably changed since then, which is up since 2020. And then there was another site that I went to where the population size is going down since then. So you don't have to stay on this site if you can't get in this site. All right. Andre and Brooklyn, y'all are still blocked. I wonder why that is. All right, I'm gonna stop sharing for a minute. Let me look and see why that might be. Are you in Canvas still? Because sometimes, because it is an approved video, so it shouldn't be blocked. Oh, I mean, it's an approved site, so it shouldn't be blocked. So make sure that you're looking at it through Clever. All right, Caleb, are you still there? Jalen, are you still there? Okay. It's like half the class can get in it. And some of you, I don't know whether you can't get in it. Oh, wow. That's cool. Thank you for sharing, Neve. All right. So yes, that's one of the questions they're asking you. What is the population distribution? So you want to include how many of each. I can't X. Okay, let's see if I put it in. Let me see if I, like you said, if I put it in, because I put it in the chat here. Let me see if I put it in the chat here. All right. I certainly will. Ethan, I'll do that. All right. Avery, see if you can. I put the link in the chat in GoGuardian. See if you can get to it from there and let me know. And if that's the case, I'll do that for the other two as well. There you go. All right. So, Andre, I'm going to do the same for you. I'm going to add it to, so let me know if you can't get in and I can add it to your GoGuardian chat. And then you should be able to get in from there. All right, so Andre, I put yours in the GoGuardian chat. And who is it, Brooklyn? All right, Brooklyn, give me a second. I'm gonna put it in yours. Okay. All right, try it now. It's in your GoGuardian chat. Anybody else that I need to add this link to your GoGuardian chat? You're still blocked. All right. It's still blocked. Now, how come it worked for Aiden? I don't know why it's not working for the two of you. I'll tell you what, do your own, rather than use my link, do your own search for, and then just put in population for Muskogee County, Georgia. And see if you get to a website on your own. And then when you do the search, use USA.org. usafacts.org for when you get your lists from your search, use the website that says usa.org, usafacts.org. See if that helps. Other than that, I don't know what to tell you. And again, let me know if you get in. Still can't. Can you do a search of any kind? It's still blocked. I'm gonna have to put that in for all right, so like I said, do a search from a different website and let me know what that website is. And then I'm going to put this one in for Mr. Phillips to see why some of you can get in and some of you can't. That's unusual. All right, so again, just doing a search for Muskogee population in Muskogee County and see if you can find one that you can get into, and then let me know what that is. You tried two and they aren't working. It's something about the two of you that is blocked. Because like I said, I'm looking at almost everybody else. And they're in. Okay. All right, I'm going to make a note of the two of you, and then I'm going to ask Mr. Phillips why that is that you can't get in, and then I'll email you on a reason. So give me a second on that. Okay, in the meantime, you can look. Okay, so that's three of you. Okay.
Yeah, it's blocked now. It loaded, and then all it showed was how much has Columbus changed, and then or Muskogee County, and then it just blocked me.
Aiden, that's you.
Yeah.
Okay. I'm sorry, Avery. Aiden. Okay. All right. So I'm gonna write the three of you all down. Thought it worked for a minute there. All right. So in the meantime, you all read the Canvas page, and I will put in a question as to why it's not working for you four. Okay, so I got 4 people, so that means everybody else is there. So if you're not on that website or not able to get to it, you need to let me know now. Aaron, are you able to get to that website? Lucas, are you able to get there? Neve. Okay, Jalen, I see you're there. Janila, are you at the site and it says it's blocked? Okay. Thank you. Okay, so if you haven't told me that it's blocked, then I'm going to assume that you can get in and I'll be expecting an answer. I got 5 people. All right, so if it's blocked for you, you read the page in Canvas that deals with population. Don't sit there and do nothing. All right, and let me go ahead and report this. All right, I haven't put the assignment folder in Canvas yet, so for now, just keep track of it, and Wednesday I'll have that up for you. I'll have it up by today, but by Wednesday for sure. All right, let me catch Mr. Phillips. Okay, so I have sent out that information and we will see what the problem is. But I probably won't get an answer back on that until next class. All right, and if you can share an interesting fact about where you fall in the demographics of that population. Like someone just shared that they fall into the 3% of the American Indians. There's 3% of the population is American Indian in Muskogee County. If you fall in a particular population, go ahead and share that in your write-up. Okay. Okay, folks. So we're good for today. Oh, I said if someone shared that we were looking at the statistics of the demographics of people or races of people in Muskogee County, and they shared that they fall into the 3% group of American Indians. So if you have a special group that you fall into, indicate that. Which part of the population are you? Okay. All righty. So time to go, folks. I'll see you next class. And for those of you who couldn't get on, I did ask Mr. Phillips to